let's consider, remember whatever I write down, you write down, y equals x, or better yet, f of x equals x. Alright, so now I turn on my graphing calculator, and I'm going to come in here and I'm going to clear this out, and I'm just going to put y equals x, hit the graph. Whoops. Let me zoom out a little bit. Zoom, standard. Alright, and so I've got this function here.
Why did it stop?
Oh, because I'm recording. There we go. All right. So I've got this function here. It's just a linear equation with a slope of 1, right? And so my parent function is this. Well, let's see what happens when I go to add a number to it. So what if I were to say f of x plus h? Well, wherever there's an x, I have to plug in x plus h. So that becomes x plus h. But let's let h equal a number. Let's say h equals 3. So then f of x plus 3, in this particular case, is just x plus 3. So now the only thing different between my parent function and my transformed function is I'm just tacking on 3. In other words, whatever I have for x and I plug it in, I just add 3 to it, and I get another number. So now watch what happens when I go to plug this into my graphing calculator. If I take, and on the second equation, I say x plus 3, well, I get the same exact line, but now it's just vertically shifted up. Keep a note of that. How much is it shifted up?
3.
3 units.
1.
And that makes sense, right? Because if I plug in 1 for x, I get 1 plus 3, which is 4. But if I didn't have that plus 3, I would just have 1. So because I'm adding 3 to each number that I plug in, it goes up. That same number. So when you see a function like this, sometimes it's a vertical shift of 3. Let's consider a different parent function. Let's consider f of x equals x squared. All right, let's graph that, see what we end up with. So I'm going to clear out all of my, and I'm going to hit x squared. Now you guys should know from your Algebra 1 days that that's a parabola that has a vertex at the origin. So now what happens if I say f of x, this time I'm going to say minus 3 just for the fun of it. Well, wherever there's an x, I'm going to plug in x minus 3, so this would be x minus 3 squared. Now, if I follow the logic that I followed in the last problem, this should shift down 3 units, but it doesn't. And I'll explain why in a second. So let's see what this does. Let me come in here and graph it. So what I'm going to do is I'm going to say, in parentheses, x minus 3, and then square that whole thing. And you're going to see that it shifts the whole thing over to the right 3 units. Yeah, some of you guys got that puzzled look on your face. Well, here's why. So this, when it's inside the parentheses, is what we call a horizontal translation, because it's inside the parentheses. If I go back to this other problem here, this is what we call a vertical translation. It's a shift. Okay? But notice this is outside the parentheses. This is not inside the parentheses. Now where this comes from is basically what occurs. This is a little different. This is really x minus 3 times the quantity x minus 3, which is actually x minus 3 times x minus 3, which is x squared minus 3x minus 3x plus 9. So So this whole thing is x squared minus 6x plus 9. This is completely different. This has a vertical shift of 9. And this shifts across the parabola. And so what it essentially does is it does a horizontal shift 3 units in the opposite direction of the sign. So because it's -3, it goes 3 units to the right in the positive direction. So let's test that theory and see what we end up with. If I say in parentheses x minus, wait, let's do plus 2, and then I square that, what will that plus 2 do? You guys are pointing. Somebody say it. Use your words.
Should go right.
Vertical.
Should go right or left?
Left.
Left. Is it vertical or horizontal?
Horizontal.
Horizontal to the left, 2 units. Let's see. Yep.
Yeah.
See how that works? Now watch this. Tell me what this one does. You ready?
Yeah.
If I say x plus 5 squared minus 7.
5 units left, 7 units
Down.
down.
5 units to the left, 7 units down. I probably shouldn't have done such a big number, but I think it'll fit.
Sweet.
Fairly.
Does that make sense?
Mm-hmm.
Okay. Now this applies to a lot of different functions that we use. Let me do one more example. You guys ready?
Mm-hmm.
If I clear all these out, and I'm going to check my mode, I want to make sure I'm in radian mode, and I am. Let's do sine of x. Okay? So this is what sine of x is. We'll talk a lot more about these trigonometric functions. Okay? What if I were to come in here, and I were to say sine of x minus 3? What do you think that would do?
Bring down. No.
Bring it
Right 3.
right
Here's my question. Is it inside or outside of the parentheses?
Inside.
Inside. So what do you think it'll do?
Horizontal shift.
Horizontal shift to the right or left?
Right.
3, let's see.
Yep.
so
Yeah,
goes
for the
in
most part. For the most part, yep. So now let's expand this a little bit more. What happens if I come in here and I say plus 2? Now what will that do?
It'll also go up 2.
Now it'll go up 2. So I'm going to shift it over 3 units to the right and then go up 2. Let's see. Is that right?
Yep.
Okay, let's do one more example. I really want to make sure that you understand. Let's do this. Let's do math. No, wait, I want catalog. So we'll do second catalog. Absolute value. Whoops, got too much stuff in there. I want to do the absolute value of x, right? You guys remember what that looks like, right? V that goes through the origin, has a vertex at the origin.
Mm-hmm.
Absolute value function, right? You guys remember that. Let's do this. Second catalog. I'm going to say x plus 1. What's that going to do to my absolute value function?
Horizontally shifted. 1 to the left.
Yep, 1 to the left horizontally. Cool. Now watch this. What if I take that same function and I subtract 3?
It doesn't work.
It's going to go down to
Well,
Yeah,
it'll
won't
be
work.
like going and then it'll be blank and then it'll continue it.
No. What is that -3? Is it inside or outside the absolute value bracket?
Outside.
Outside. So what is that going to do to it?
Down
Move
3.
it down, but
Yeah.
it can't move down. to
Oh no, it
the
can
value.
because it's
It's absolute value.
it's outside the absolute value. Wait,
Okay, so some of you guys are worried because you're like, absolute value can't be negative, and if it goes below the x-axis, it'll be a negative y value.
is
Right.
the absolute?
So that's what you're freaking out about, but guess what?
Up 3?
The absolute value is just affecting what's in the parentheses, right?
Correct. He figured it out. The absolute value is only, in other words, when the stuff inside the parentheses has to be positive, but I can subtract a negative number from a positive number, right?
Uh-huh.
Yeah.
So absolutely correct. That was a great assumption. The absolute value is only affecting the stuff inside the parentheses. With regards to the graph, because I have a +1 here, I'm going to go 1 unit to the left. And because I have a -3 here, I'm going to go 3 units down. So when I look at this graphically, my parent function, which is the blue line, is shifted over to the left once and down 3. Does that make sense?
Yeah.
Okay, so that's what we do with the parent function. So I said all that stuff because guess what we're going to do? Example number 1. So now for example number 1, I have y equals x, and then I have y equals x minus 2. So what's going to be the difference between the two?
It's going to move 2 down.
Yeah, this is just going to shift down 2 units. So now this you can verify graphically by just plugging it in your calculator. So I'm going to come in here, clear this out, put x, and on this one I'm going to clear this out and hit x minus 2. And graph. Oh, I used the wrong colors for my markers, but you see that the red line is 2 units below the blue line, vertically speaking. Does that make sense?
Yep.
All right, now we can verify this on our calculator with the table of values as well. What's going on is whatever, let me make this number a little smaller. Whatever my y value is, that's just my function y equals x. I'm going to subtract 2 from it. So notice that the red column is always 2 units less than the blue column. So when x equals 8, y equals 8 for my first function. And then for my second function, x minus 2, I'm just going to subtract 2 from 8 and I get 6. See how that works? Graphically, this is what it looks like. All right. Let's move on to example number 2.